Alright, so let's just get right into it. Let's start by substituting u equals e to the x plus 1, which means du is equal to e to the x dx. If we divide both sides of this relation by e to the x, we end up with dx equals 1 over e to the x du. Since u equals e to the x plus 1, if we subtract 1 on both sides of this relation, we end up with e to the x equals u minus 1. So now we have an expression for e to the x in terms of u. So instead of 1 over e to the x du, we can just rewrite this as 1 over u minus 1 du. So if we substitute all of this back into the expression, we end up with the integral of 1 over the square root of u times parentheses u minus 1 du, since the square root of e to the x plus 1 becomes the square root of u, since u equals e to the x plus 1, and dx is just replaced by 1 over u minus 1 du. Looking at what we have now, we have a square root u term in the denominator multiplied by u minus 1, which is a linear factor. Let's just try substituting v equals the square root of u, just so we can deal with the square root of u term in the denominator. And if we do that, then dv is equal to 1 over 2 square root of u du. If we multiply both sides of this relation by 2 square root of u, we end up with du equals 2 square root of u dv. And since we let v equal the square root of u, 2 square root of u dv is just equal to 2v dv. We would also like to find an expression for u minus 1 entirely in terms of v, and since we let v equal the square root of u, this implies that v squared is equal to u if we just square both sides, and if we subtract 1 on both sides, we just get u minus 1 equals v squared minus 1. If we substitute all of this into the expression, we end up with the integral of 1 over v times parentheses v squared minus 1 times 2v dv, since the square root of u just becomes v, u minus 1 becomes v squared minus 1, and of course du is replaced by 2v dv. If we multiply the two terms together and simplify, this just becomes the integral of 2 over v squared minus 1 dv, since the v and the v in the denominator cancel out. We can factor the denominator and rewrite this as the integral of 2 over parentheses v plus 1 times parentheses v minus 1 dv, and now we need to use partial fractions to split this into two smaller fractions. So here's how we do the partial fractions. We start with 2 over v plus 1 times v minus 1, and set that to equal a over v plus 1 plus b over v minus 1, since the denominator contains distinct linear factors. If we multiply both sides of this equation by v plus 1 times v minus 1, we end up with a times v minus 1 plus b times v plus 1 equals 2. If we plug in v equals 1 into this new equation, we end up with 2b equals 2, which implies b equals 1. If we plug in v equals negative 1 into this equation, we end up with negative 2a equals 2, which implies a equals negative 1. If we plug in these solved coefficients for a and b into the expression a over v plus 1 plus b over v minus 1, we get that 2 over v plus 1 times v minus 1 equals negative 1 over v plus 1 plus 1 over v minus 1, which is the same as negative 1 over v plus 1 plus 1 over v minus 1. So this means we can rewrite the integrand as negative 1 over v plus 1 plus 1 over v minus 1. And if we integrate this term by term, we end up with negative ln of the absolute value of v plus 1 from the integral of negative 1 over v plus 1 plus ln of the absolute value of v minus 1, which comes from the integral of 1 over v minus 1, plus the constant of integration c. We substituted v equals the square root of u, so if we substitute the square root of u back in for the v, we end up with negative ln of the absolute value of the square root of u plus 1, plus ln of the absolute value of the square root of u minus 1, plus c. And since we also substituted u equals e to the x plus 1, if we substitute that back, we end up with negative ln of the square root of e to the x plus 1 plus 1 plus ln of the absolute value of the square root of e to the x plus 1 minus 1 plus c, which is the final answer.